Hello, everyone. My name is Aayush Kapoor, and I'm an engineer at Vercel working on the AI SDK team. Thank you. Which one is this? Green one? So by a show of hands here, before we get started, how many of you have heard of the AI SDK before? Okay, nice. How many of you have actually used or built something with the AI SDK before? Okay, well, hopefully by the end of the session, that number only goes up. So for those of you who don't know what the AI SDK is, it is the AI toolkit for TypeScript, meaning it's a free and open source library that you can use to rapidly build web applications that use AI. And you can get started with the AI SDK by installing it via a simple command like npm iai, or use any other package manager of your choice. And we work across a lot of different frameworks, and that's kind of the beauty of it. We support Next.js, Svelte, Vue, React, and support runtimes like Node.js. So now that everyone has a little bit of a preface of what the AI SDK is, the main focus of my session here is going to be to get you all a little bit more familiar with the fundamentals or the basic building blocks of the AI SDK, and then see how we can use those said fundamentals and building blocks to build something like a deep research agent. Just an FYI, all the code and the examples and the code snippets that I'm going to be showing you can access them by going to this website. And what you're going to find there is just a step-by-step process of my slides here. So if you wanted to code, I'm not going to be coding live on the session, but if you wanted to try whatever code snippets I'm going to be showing you, feel free to do so. Go at your own pace. No need to rush. But with that out of the way, let's just dive right into it. So the first fundamental, or the first primitive that I'm going to talk about, is called the generate text function. And this function is kind of what it sounds like, right? You would use this helps generate some text by making a call to the LLM. And diving a little bit deeper into the code snippet that you see here, you'll see that we're defining a simple main function, which is going to be asynchronous in nature. We are calling the generate text function, which is imported from the AI package, which is the AI SDK package. And what we're going to do is we're going to specify the model that we want to use. In this case, it's going to be OpenAI's GPT-4o mini. And then we pass in a simple prompt. In this scenario, we're just going to say a simple hello world prompt. And when you log out the results, you'll see something like this. Hello, how can I assist you today? And that's as simple as to get started with the AI SDK and get building with it. So the beauty of the AI SDK is one of its core features is its unified interface. Meaning if you had to work across different providers, different models, you can do so without changing your entire framework that you've built upon by just swapping out a line of code. So as an example, right, let's try asking the GPT-4o mini model something like, okay, when is the AI developer conference in New York City? Now I know for a fact that since this model had a knowledge cutoff sometime in 2024, right, it's going to output something when I try to call the resulting text. It's going to say something like, I don't have real-time information. It's somewhere annually, it's going to give an estimate, kind of like an AI stop answer. So what if I wanted to use a model that actually does have the capability to get real-time information? Maybe something like Perplexity. So how you would do that in the AI SDK is I'm simply going to import the Perplexity package from the AI SDK, and I'm just going to swap out the model. Instead of using OpenAI's GPT, I'm going to use Perplexity's Sonar model. And now the prompt remains the same. Nothing else has changed. And now if we log out the resulting text, it actually does know when the AI developer conference is. It is today. OK, that's verified. And awesome. So that's as easy as it is to change models. And we currently, you can do this with Anthropic, Google, XAI, Hugging Face, a bunch of other providers. The AI SDK currently supports more than 30 different packages and providers. So feel free to try them out. And that covers our first fundamental. The second primitive that I'm going to be talking about is something called function calling or tool calling. So we saw how we can get the model to generate some text. But what if we wanted it to do a little bit more? What if we wanted to expand its context? What if we wanted it to like interact with the outside world a little bit more? So this is where the tool calling comes in. And if this code seems a little bit scary, I'm just going to dive into it a little bit. But what's happening here is we're still passing in a model. We're still passing in a prompt. But now we're going to also pass in something called the tool parameter. And how the tool parameter works is we're basically passing in as context to the model a list of tools or functions that it has to call at its runtime. So we're going to start with a very simple example here. And when I say simple, I mean simple. We're going to tell the model, help us add 2 numbers. So the tool definition is going to look something like this. We're going to define the tools parameter to be an object. And when specifying a tool, there's 4 things that you need to be mindful of. A, you need to pass in the tool name. You need to pass in a description. And this description is what the model is going to use as context as to understand when to run this tool. You're going to define an input schema, which is basically the arguments that the model is going to take, right, as the arguments like you would pass in a function. And then finally, every tool needs to have an execute function, which can be asynchronous in nature. So you can have long-running tasks or whatever. But in our case, since it's a simple add 2 numbers tool, we're going to define the description, OK, add 2 numbers together. The input schema is going to be 2 numbers that we're going to take, num1 and num2. And we're going to finally return, taking the 2 numbers as input, we're going to return their sum. And now when I log out the result.tool results, you're going to see an object that looks something like this, which basically tells us that the model ran this tool name called add numbers. It took in the input for num1 as 6. It took in the input for num2 as 7. And then it generated the output 13. An interesting thing that you'll notice here, though, is that I'm actually not generating the result.text. This is not the textual answer that the model generated. So how can you use that? How can I get this output 13 to be incorporated in the final text that the model generates? So in order to do that, what you'd have to do is we're going to import a helper function from the AI SDK called the step count is. And we're going to define another parameter along with the tools called the stop when function. And we've designed the library to be really just understandable by how it's framed. So if you kind of like parse in just natural language, right? Stop when step count is 2. I feel like it's a little self-explanatory. And what I mean is, so by default, the generate text function and all the other primitive functions in the AI SDK, they only run for 1 step, meaning they only make 1 call to the LLM. And in that call, in the tool call, for example, what's happening in the background is that the AI SDK sends this tool list as context to the model. The model generates something called the tool call object. And we, at the AI SDK side, we parse that tool call, and then we invoke the execute function of that tool. But in that step, we still need to pass the previous tool result object that we generated back to the model. And how we do that is we need to define that let the model run for at least 2 steps. We got the first step where it generated the tool call. Now the second step is going to be we're going to pass the tool result that we invoked back to the model. And once you do that, then if you log out the resulting steps.length, we'll see that it executed for 2 steps. First step being the tool call. Second step being passing the tool result back to the model and how you get the text back. And resulting text now is going to be 6 plus 7 equals 13. Awesome, pretty sweet. So this is kind of how you define the model to let go, like run in a loop kind of a situation, kind of understand whatever the context that it needs to answer the user's prompt. So now that we know that we can run this in a loop, how about we try adding in another tool, right? What we want, ideally, for the model is to run these 2 tools and answer the user's query. So I'm going to add a really complex tool. It's going to be the get weather tool. I'm kidding. It's not actually that difficult. But it's, again, we're going to define 3 things here again. First, we're going to pass in a description, which is going to be get the current weather at this particular location. then the input schema here is going to be interesting. We're going to pass in the latitude, as well as the longitude, as well as the city of the place we want to get the weather for. And the execute function is making just a simple fetch call to this particular endpoint. And once we parse that response back from that API, we're just returning the temperature for that particular city. And now the prompt I'm going to pass. So this tool is going to be in addition with the previous add numbers tool. And the prompt here is going to be get me the weather in SF and New York City, and then add them together. Ideally, we wanted to call both of these functions. An interesting thing, again, that you'll notice here is that we're not actually passing in the latitude and longitude, right? But we defined the getWeather tool to actually take that as input. So this is where a really cool feature of where we tap into the inference capacity of all these models, wherein just based on this prompt and the tool definitions that we've provided, we let the model infer what the value of latitude and longitude is going to be. I'll show you that in a minute. But now if you execute this entire code, we'll see that the steps that it ran for was 3, meaning it made probably two calls, generated some results, and then passed them back to the model. And it tells me, okay, the current weathers in San Francisco are this, in New York is this, and it adds them together. Awesome. It actually does what we asked it for. But you may be wondering, what if the model is just hallucinating, right? It's really likely that it just had that information in its training data. I mean, it's smart enough to do that addition. So how can you verify that the tools that you're defining are actually being called at runtime? And how you do this in the AI SDK is we basically still, function hasn't changed, but what we're doing now is we're just parsing out from the result each of the steps that the model, that we generated, right? And the final object of the steps is going to look something on the far right. It's a little blurry, I apologize for that. But basically, when you log out the all tool results, the first tool result that you see is just the first part of it. And if you dive a little bit deeper into it, you'll see that as input, the model inferred that the latitude for San Francisco and the longitude of San Francisco is what I'm assuming, and it's probably correct, is 37.77, and longitude is -122. So it kind of just inferred that without us actually needing to specify it. And I think this really unlocks a lot of cool features and stuff that you can build just based on inference capacity, and you want something as the output, you could just do a lot of stuff with just a simple function call. Awesome. So that covers 2 really important primitives that we've defined. That brings us to the third and final primitive that I'm going to be talking about in this session, which is how would you generate, instead of some text, some structured output, right? What if I want to generate some JSON schema, which is much more easier to parse rather than extracting information from the text that the model generates? So how you do that in the AI SDK, there's 2 ways, but I'm going to focus on a really, really powerful function called the generate object function. And generate object, similar to the generate text function, kind of works in the same way. In the code snippet that you see here, we're gonna import it from the AI SDK package, right? We're gonna call the generate object function. Again, this is gonna be in a main asynchronous function. We're still passing in a prompt. We're still passing in a model. And you know, it's wintertime in New York, and I'm a big hot chocolate guy. So I kind of want to ask the model, okay, give me the 10 best hot chocolate spots in the city, but then also tell me the neighborhoods that they're in. You know, I want to see what's convenient. And so now I'm going to define the schema of it as, I'm going to define, so in the generate object, instead of generating some output, you would have to define this schema property, which is going to be, this is just a simple parameter that you would define in the generate object function. And that schema, I'm going to define a final object, which is going to be taking the key as the spots. And the spots is going to be an array of objects. And each of those objects is going to have a cafe name as well as a neighborhood. And we're going to define this by using Zod. If you don't know what Zod is, if you haven't checked it out, highly recommend it. It's a schema validation library in TypeScript. And that combined with the AI SDK is just so powerful. So you get type-safe inputs and outputs at execution. And now when I log out for this entire snippet of code, if I log out the result.object, not text, I will see an object, something like on the right. It defines an object, taking in the spots as the key value, and has a list of cafe names and the neighborhoods it's in. I don't know how accurate this list is, but keep an eye on my blog. Awesome. So we covered 3 really powerful fundamentals on how you can get started with building with the AI SDK. The generate text function, importing tools and calling tools, and then finally, the generate object function. Which now brings us, and now we're ready to build something really useful in the world, right? Chances are your workflows are going to be a little more complicated than adding 2 numbers and getting the weather from a location. So an example we're going to look at is we're going to see how we can build something like a deep research agent. And the idea here is that if you're familiar with other deep research agent tools out there, something from like OpenAI or Google, you would basically define in a prompt, a simple prompt. In our case, we'll take, okay, electric cars. And based on the depth and the breadth that you want the model to like search into, like you want the agent to like find out the information, you would pass in a depth and breadth. And let's say the breadth for our example is going to be something 3. It's going to define 3. So for that initial prompt, we're going to generate some subqueries. We're going to generate 3 subqueries. And if our depth is more than 1, then you go down a level further, and we say for each of those subqueries that we generated, we generate 3 sub-subqueries, right? I hope the diagram makes it a little clear of what I'm trying to say. And this is the main idea and the logic that we're going to be using to build our deep research agent. The rough steps look something like this. We're going to take in an input. This is going to be a simple prompt. We're going to generate some search queries based off that input and the breadth that we define. We're going to map through each of those queries. And after we did that, what we have to do? We have to search the web, right? Because that's how we're going to get the content. We're going to search the web. We're going to get some content back, right? Now we need to analyze whatever the search results gave us. We have to see, is it even relevant to the prompt that we initially asked it? And then we need to analyze the result. If it is relevant, then we kind of go down a further deep hole. Okay, we're going to generate some learnings now and some other follow-up questions. And the follow-up questions come in play when the depth is more than 0, right? So in that case, we do the entire process again. So it's kind of like a recursive flow. Okay, how do we get started? So again, I'm going to be showing a lot of like code snippets here. So if you want to like follow along, if it's a little too much to follow for, go at your own pace and you can find all of this code. So you need to like start typing right now. I'm just going to be walking and explaining the code that we're going to be writing. And let's get into it. So the first step, we're going to define a simple take input. This is going to be our prompt. And okay, so the prompt is, what do you need to be a D1 shot put athlete? And if you're wondering why I've chosen such a niche prompt, it's because I heard in a talk somewhere by Google when they were building their own deep research agent that this is the kind of prompt that they used to evaluate how well their agent is performing. So this is a standard that we're going to be going with. The next step in our process, if you remember, was to generate some search queries based off this initial prompt. So here in this function, we're defining a generate search queries function. It's going to be asynchronous in nature. It's going to take in our first initial query. And we're calling the generate object function from the AI SDK. It's going to take in a main model that I've defined. You can define it to be OpenAI's GPT-5 or whichever model that you may please, Anthropic's. And it's pretty simple. The prompt here is generate n number of search queries for this following prompt. And n here is the breadth that we initially defined. And since we're using the generate object function, what we're going to get as the final schema is, we're going to get a final schema from this function is a queries array, which is just going to be an array of strings, basically having 3 follow-up search queries. So that's the first function we defined. The second function is how do we actually search the web, right? And I'm going to use a search API called Exa AI. If you haven't used it, I highly recommend it. It's a pretty sweet API. And what we're doing here is basically we're importing the required classes from their package. We're going to define a type, which is going to be the search result type. And basically, this is so that our final output kind of makes sense. And our final output from calling X's function is going to be like, OK, I need the title of whatever searches you made. I need the URL. And I also need the content that you got from parsing that URL, like whatever content's available on that site. So this is exactly what the search web function is doing. We're going to call the search and contents function from Exa. And the results that we get, it's just going to store it in that type search result format. This is going to come in later. Awesome. So this was the third step. Second step, we're searching the web. If you remember, now we searched the web, we generated some queries. The next step in the process was analyze the results that we got, and generate, if they're relevant, generate some learnings. So we need to define a generate learnings function, which is going to look something like this. Again, the generate learnings function is going to take in the query, the initial query, and now it's going to take in the search result that we're passing it as well. We're calling the generate object function again. And I told you, it's a really powerful function, so it's going to keep popping up a lot, just because it helps us, make something like this so much more easier and get like final type safe outputs. The main play in this function is going to be in the prompt, right? It's a pretty explicit prompt here that we're defining because we want to get some actual insights from the search that we're doing. So the prompt is something like, okay, this is what the user is researching, and you have this set of following results that were deemed relevant. Now your job is, based on those search results, generate me an object that looks something like, it's going to be, it's going to take in one key as the learnings, which is just going to be the entire string. And the second schema that we're going to define is going to be the follow-up questions, which is, again, going to be an array of strings. So we kind of have, from the search results that we got, we know now, OK, these were relevant. We generated some learnings. And then we can use that as the final output in our accumulated research. Awesome. Now the next function is kind of just to like tie it all together. This is called the search and process function. And it's going to be not generate object. It's going to call the generate text function from the AI SDK. We're defining two variables, pending search results and final search results. And I'll explain in a minute how they come into play. But the tools that we define here are going to be the search web tool and then the evaluate tool. And OK, let's look a little deeper into what those tools are. So the search web tool, if you guessed it, it's basically calling the initial search web function that we defined with Exa AI. And we're saying, OK, search the web, return whatever results you got. And in the pending search results that we define, like the variable that we define, we're just going to append all the results that we got so that we keep a track of results that haven't been evaluated yet. And that's exactly what this function here is doing. So once we've done that, we're going to go on to the second tool that we defined, which is called the evaluate tool. And also, again, this looks a little bit scary, so I'm just going to dive in. I'm just going to go step by step. We're going to tell this tool, OK, you need to tell the model, you need to call this tool to evaluate the search results that are in our pending search result. So if you look at the execute function here, we'll see that we're calling inside the tool a generate object function. And what we wanted to do is, again, we wanted to output if the search result is either relevant or irrelevant. So we need to basically classify it into two types, right? And that's where the generate objects, another feature comes in, where instead of defining the schema, you would define the output. And in this case, it's going to be output of the type enum. And enum lets you just let the model output different types of output that you may want. In our case, it's going to be either it's going to output relevant or irrelevant as the final result from the tool evaluate tool. Now, if we look at once we did, basically what this function was doing is now we know, OK, this particular search is classified by the model as relevant, and some of them are going to be classified as irrelevant. But now, if they're irrelevant, right, we need to pass in like a feedback loop to keep the model improving. OK, this is not relevant, so you need to actually call this function again, right? Because what we're going to do is we're going to define the step count function to be a little bit higher. And this way, we keep like a feedback loop going. The agent kind of keeps on learning from the results that it generates, and it keeps calling these functions and gets better at the results that it generates. And that covers the search and process function. So we define a lot of functions here, right? But how do we kind of go back to our initial flow and assemble them all together? So this is what the final function is going to be defined. It's called the deep research function. And this basically simplifies it a lot. So we're going to pass in a query. We're going to pass in some depth and breadth based on how complicated you want your agent to be. And then we're just going to go step by step. So the first line, it says, OK, generate some search queries. It's going to call in our first function and generate an object of array type with a list of strings, with a list of subqueries based on the breadth. Then for each of those subqueries, we're going to call the search and process function, which is what that function is going to do. It's going to search using XS Search API. It's going to call, it's going to evaluate, it's going to generate some content, and then it's going to evaluate within itself if that search was relevant or not. And it's going to store it in the final search results output constant that we had defined. And for each of the search results that were deemed relevant, right, it's going to be a bunch probably of results that are deemed relevant. We again parse through each of those search results. We again define a for loop. And now we call finally, since we wanted to generate some learnings as we analyze the result for learnings and some follow-up questions, what we need to do is for each of those search results, call finally the generate learnings function. And that's about it. You're going to get a final learning and follow-up questions parameter. And we're going to define a simple main function here to kind of like orchestrate all of this again. We're almost there. But we're missing one thing. We haven't really taken into account the depth, right? So what if the depth is not more than one? So what then needs to happen is we're not actually using the learnings that we generated, right? The learnings constant isn't used in the entire snippet of code. So we need to feed it back to the deep research agent function. And this is where the recursive function that I talked about comes in again. And before we do that, what we have to do now is we're just going to find some types again, just so that our final result and the outputs that we generate make sense. We're going to define a final variable called accumulated research. And it's going to store in your queries. And at each step, we're going to store in the first prompt that it generated. We're going to store in the subsequent subqueries that it generated. We're going to pass in the search results that it generated. And we're going to store the learnings as well as the follow-up questions. This basically ties the whole thing together. And the last step to actually make this function recursive is going to be, well, obviously, if it's going to be a recursive function, we need to define a base case, which in our case is going to be if depth is 0, just return whatever accumulated research you have at this point. And finally, we're going to have a constant called new query, just going to accumulate our initial prompt. And again, this is just more of like prompt engineering coming into play as well, because how you define the structure and the format that you give the model kind of refines your output of what you get as well. So the new query is going to be like, OK, this is the overall research goal. This is the previous search queries. And these are the follow-up questions. Go wild. Do what's best. And answer the user's query as best as you can. And finally, we call the deep research function within the deep research function. And make sure that you're actually decreasing the depth by 1 or how much ever you want, because otherwise, chances are your model will just keep running and never stop. You never want that. And that's about it. That covers the deep research agent. This is just a little extra function that I've added for all the results that we got. What we want to do is want to make sure that we get I want a final markdown report just to summarize whatever I've learned. And so this is just going to be a simple generate text. I'm going to be defining a function called generate report. It's going to be a simple call to the generate text function. No tools, no output schema, just simple prompt, giving it the accumulated research. And I tell it, OK, just assemble it all by giving it a system prompt that I've defined. Give me a simple markdown file. And I'm going to coordinate all that in the final main function. We pass in the original prompt. What do you need to be a D1 shot put athlete? And finally, after it's generated the results, we're going to call generate report function. And we're going to see a final file that looks something on the right. Feel free to try this out. What we recommend at AI SDK, when you're building apps, is how you experiment with stuff. There's a couple cool features that were kind of abstracted when I was talking over, the inference capabilities, the defining the output object. So the best way, to actually learn is kind of just get your hands dirty, experiment, play around, and that's when you see the best results. Awesome, we did it, guys. Hell yeah! And now it's the best part. We can actually prompt it something like this: make an application that results in 1 billion ARR. Make no mistakes. That part's pretty important. Don't forget that. No, not really. We're not there yet. But you are going to be a step closer. And with that, if you ever want to look at more ways to build examples like these, agents like these, we have a whole documentation site with a bunch of other primitives that you can use. We have generate images, generate objects, a bunch of, you can stream results as well. Definitely check out our documentation site at ai-sdk.dev. And if you have any questions for me, if I can help you with anything, if you're building with AI SDK, connect with me on, the QR code is going to be my LinkedIn. Can I add me on Twitter? I'm really active on Twitter, and I'll be happy to answer your questions. And we're really excited to see what you guys build with AI SDK.